Hello guys, in this video we will be discussing about finding the second derivatives of implicit functions. Implicit function is a function that does not define explicitly the function y with respect to x. Our main objective is to differentiate an implicit function twice. Now we have here a function y times 1 plus x equals x. Show that 1 plus x times the second derivative of y with respect to x plus 2 times the derivative of y with respect to x is equal to 0. So we are going to show this formula upon manipulating this function. So we have here y times 1 plus x is equal to x. First thing to do is that we are going to get the derivative of this function. We are going to get the first derivative. How to do that? Now, we are going to get the derivative of the left and the derivative of the right. Now, take note that the left has two functions. We have the first one and the second one, which is 1 plus x inside the parentheses. So we will treat this one as our u, and we're going to treat this one as our v. So if we have u times v, this is actually product rule, which means that the derivative goes this way. We have u times the derivative of the v plus copy the v times the derivative of the u. Take note, v prime is the derivative of v and u prime is the derivative of u, such that if we have y, the derivative of y is y prime. And if we are going to get the second derivative, this can be written as y double prime. This y prime is the first derivative, while this double prime is the second derivative. It's the same thing when I say dy over dx. So dy over dx is the first derivative, the same thing with y prime. And y double prime, this can be written as the derivative, second derivative of y with respect to x. So you can write y prime as dy over dx and y double prime as the derivative or second derivative of y with respect to x. So going back with the product rule, this is the formula in using the product rule, and this is what we're going to do for the left side. So this is our u, and the second one is our v. So first thing to do is to copy the u, which is the y. So you have y times the derivative of our v, or the derivative of 1 plus x, which is 1, plus copying the v, which is now 1 plus x, times the derivative of y, which is now derivative of y with respect to x, and also differentiating the right side, which is 1. As you look at the left side, this is following this formula. We have u v prime plus v times the u prime. Next thing to do is to simplify. So y times 1, that's y, plus, on the second term, we are going to use distributive property. So distributing dy over dx to every term of the function inside the parentheses. So 1 times dy over dx is dy over dx, plus x times dy over dx is x times dy over dx, which is now equal to 1. So we are done with our first derivative. Now next thing to do is that we are going to differentiate for the second time. So let us differentiate again. What is the derivative of y? This is dy over dx plus copying the operation. What is the derivative of dy over dx? That is the second derivative of y with respect to x, which is now this symbol over this plus this is still product rule, so our u here is x and our v here is dy over dx. So we will be using the same formula for the product rule from this third term. So getting the derivative of x, or copying the x because that's the u, so we have x times derivative of dy over dx is what? The second derivative of y with respect to x plus, because we have here addition operation, copying dy over dx, we have here dy over dx times the derivative of x, which is 1. So basically, this terms here is actually the derivative of this term. And the derivative of the right, derivative of a constant is 0. So we are done with our second derivative. The next thing to do is that we are going to simplify. So copying dy over dx plus copying the derivative of the second derivative of y with respect to x plus x second derivative of y with respect to x plus, what is dy over dx times 1? That is dy over dx, which is now equal to 0. Combining similar terms, take note that this part here is the same with the last term. So we are going to combine that. So we are going to write on this part. So first thing to do is to copy dy, second derivative of y with respect to x, and the third term x, second derivative of y with respect to x. So this is now the derivative of y with respect to x plus x, the derivative of y with respect to x. So we are copying first the second and the third term, and then followed by the first and the fourth. But take note that they are having the same variable, dy over dx. So we are going to combine that. That would become 2 dy dx plus 2 dy over dx, which is now equal to 0, copying the right side. Take note, the first term and the second term has a common, and the common is the second derivative of y with respect to x. So we are going to factor out dy over dx. So what's left here is 1, and then what's left on the second term is x. So we have here 1 plus x, letting the second derivative of y over x squared out from the equation. So this is now the second derivative of y with respect to x plus copying the second term with respect to x. Is now equal to 0. So what have you observed? We arrive with this figure. So we have shown that 1 plus x, the second derivative of y with respect to x, plus 2 derivative of y with respect to x equals 0 is the second derivative of our implicit function y times 1 plus x equals x. The solution is now demonstrated. Another example. For our second example, we will have another implicit function and another equation or another thing to prove. So assuming we have here given xy is equal to sine x. This is our implicit function, and we're going to show that we have here x, the derivative of y with respect to x, plus 2 dy over dx minus xy, or shall I say plus xy is equal to 0. So at this point, we are going to prove that this implicit function has a second derivative of this one. So first thing to do is copying the function xy sine x. Then we are going to differentiate both sides of our function. We will get the first derivative. Take note, this is product rule. Our first function is x and our second function is y. So we are going to use product rule. So this is now x, copying. Y, the derivative of y is dy over dx, plus, copying the y, times the derivative of x, which is 1. So we are using the product rule, u v prime plus v u prime. And getting the derivative of sine x, which is cosine x. Simplifying, this is now x dy over dx plus y is equal to cosine x. This is now our first derivative. Now let's proceed to our second derivative. Now the first term is actually having two functions, x and dy over dx. So still we're going to make use of the product rule. So copying the x, getting the derivative of dy over dx, which is now the second derivative of y with respect to x, plus copying dy over dx times 1, which is the derivative of x. So this is our derivative for our first term. Now let's proceed, copying plus. What's the derivative of y is dy over dx. And take note, the derivative of cosine x is negative sine x. This is the derivative of trigonometric function. Now at this point, we are going to simplify, copying x, the second derivative of y with respect to x. So this is now x, second derivative of y with respect to x. And then what is dy over dx times 1? It's itself dy over dx plus dy over dx. That's similar term, second and third term, so that would become 2 dy over dx. So plus 2 dy over dx, or you can write that way, equals, now what is negative sine x? Negative sine x is equal to what? Negative xy, coming from the original implicit function. So this will become negative xy. Now transposing negative xy, this will become x, second derivative of y, plus 2 dy over dx. From negative, it will become positive xy equals 0. What have you observed? It's actually the same second derivative that we are going to prove. The solution is now demonstrated. Thank you for watching.